So, long division, the way that we write it out is we write out what we're dividing. So the 2,748, we're dividing it by 13. And for long division, the way that it works is you look at your number from left to right, and you see, what can I divide 13 by? And I have to go to two numbers. See, when I get to 27, you can divide 27 by 13. 27 divided by 13 is what? 2 with a little bit extra, right? So now when we're writing out long division, we're going to write a 2, and it's important where you write the 2, because I'm writing the 2 over the 7, which is in the hundreds column. Because really what that 2 is going to represent is 200. What is 2 times 13? 26. So we're going to write 26 underneath, but because we're writing it underneath the 27, this is really 2600. You don't have to write those zeros. You might not have written those zeros when you learned long division. But by putting a 2 here, which represents 200, 200 times 13 is 2600, and then we subtract, and when we subtract, we're going to be left with 148. And that is one section of the process. We had 3 steps. We looked at the first set of numbers. We figured out what we could divide. So we saw the 27, said 2 13s go into 27. You wrote 2 times 13 is 26, and then subtracted. And we get a new number, 148. Now we redo that process that we just did with 148. So you look at the first couple numbers, 14. How many 13s are in 14? 1. So we put that in our tens column. 1 times 13 is 13, but since that's in our tens column, that's really like 130. It's like 10 times 13. And we subtract again. And we just did the same 3 steps a second time. We do it, and we get a new number, we do it again. Now we have 18. How many 13s go into 18? 1. 1 times 13 is 13, subtract again, and we get 5. 13 doesn't go into 5, that's our remainder. 211, remainder 5. So if you did 13 times 211, you'd get 2,743. You would be off by 5, and that's why there's a remainder of 5. So for this next one, we got 4,212 divided by 27. You start from the left. How many 27s are there in 42? 1. So you'd put that 1 over the hundreds column. 1 times 27 is 27. Put zeros there, and you could subtract. You're going to get 2, 1, 5, 1. So now if we look at the first 2 numbers, the 15, do 27 go into 15? No. So we'll have to look at the first 3 numbers. How many 27s fit into 151? 5. 5 times 27 is 135. That's in our tens column, so we can add that extra 0. And we subtract again. And we get 162. How many 27s in 162? 6. 6 times 27 happens to be perfectly 162, and we get a remainder of 0. So we know that 27 times 156 is exactly 4,212. This is long division with numbers. Now we're going to learn long division with algebra. And the idea is quite similar. So we're going to go down to here. We're going to do 3x squared minus 4x plus 5. That's what we're dividing, so we write that inside our divisor sign. And we're going to divide by x minus 2. 3x squared. So just like we did when we were dividing by numbers, we went from the left and said, How many 13s fit into 27? Now, if we're going from the left, we see a 3x squared. And what I'm going to get you to do is I'm going to get you to ask, is there a way that you could multiply this number out in front to get 3x squared? What would I have to multiply x minus 2 by to get a 3x squared? 3x. A 3x. And since it's a 3x, we're going to write that over our column where we have just x's. So the first step in long division with algebra is you look at your first number in your polynomial, which is a 3x squared, and you ask yourself, what would I have to multiply x minus 2 by to get that 3x squared? And the answer is 3x. What did we do in our second step of long division when we had the number up there? When we had the 2, we said 2 times 13, we wrote 26. So now we're going to do the same thing. 3x times x minus 2. Well, 3x times the x is going to be 3x squared. And 3x times the minus 2 is going to be minus 6x. In long division, what was our next step? We subtracted. We're going to do the same thing here. But because we have more than one term, we're going to put it in brackets before we subtract. So here, 3x squared minus 3x squared, we get 0, which is good. And here, a minus 4x minus a negative 6x is plus 2x. This is where you're going to make your mistake, is in your adding and subtracting. And then 5 minus nothing would still be 5. So we just did 3 steps for this long division with algebra. We looked at the 3x squared. We said, what would I have to multiply x minus 2 to get the 3x squared? And we said, it's going to be 3x. Then, step 2, we took that 3x and multiplied it by the x minus 2 to get 3x squared minus 6x. Step 3, put brackets around it and subtracted. And now we've got a new set of numbers, 2x plus 5. And we do the process again. Now what's my first number? 2x. What would I have to multiply x minus 2 to get a 2x? I'd have to multiply by a 2. I'm going to just switch colors so we can see we're doing the same thing again. Step 1, we figure out that that's going to be a 2. Step 2, we take that 2 and we multiply it by x minus 2. So we get 2x minus 2. Step 3, put brackets around it and subtract. 2x minus 2x is 0. 5 minus a negative 2 is plus 7. That's going to be our remainder. Yes? Oh yeah, thank you. Good eye. This is going to be negative 4. Oops, black color. And then 5 minus negative 4. Oh, look at this. So good. Such an easy save there. 5 minus, that looks like a 9, doesn't it? Perfect. Yes? The outside negative here and here is because we always subtract. So we show that by having a negative outside there, saying I want to subtract all of that. And then you have to remember when you're subtracting more than one thing that that negative gets distributed to both of them. Okay? Number one mistake students make is they seem to be okay subtracting at the beginning, and when you get so close to being done, they'll go 5 minus 4 and write 1 as the remainder because they're so excited about getting done the question that you're going to forget on the very last one to distribute that negative. So let's try another one. Let's try the second one. 2x cubed minus x squared minus 2x plus 1. So that's what we would put inside here. 2x cubed minus x squared minus 2x plus 1. And we're going to divide by x plus 1. So again, same process. We start by looking at our biggest thing, which is the 2x cubed. What could I multiply x plus 1 by to get 2x cubed? 2x squared. We write that over our x squared column to keep everything nice and neat and orderly. And then we multiply the 2x squared times the x plus 1, which will give us 2x cubed, and 2x squared times plus 1 plus 2x squared. Put brackets around it and subtract. This will be 0. Minus x squared minus 2x squared will be minus 3x squared. Minus 2x plus 1 will still be there. And now we start the process again. So I'm going to switch colors. Now my biggest number is a minus 3x squared. What could I multiply my x plus 1 to get that? Minus 3x. So I'll write that over my x column. Minus 3x times x is minus 3x squared. Minus 3x times plus 1 is minus 3x. Put brackets around it, we're going to subtract. Minus 3x squared minus minus 3x squared will be 0. Negative 2 minus a negative 3 will be plus 1 and bring down the 1. And then 1 is now my biggest number. What do I have to multiply x by to get x? 1. 1 times x is x. 1 times plus 1 is plus 1. When you subtract, you get 0. So this one has no remainder. Now, what we are developing in this chapter is we are developing a way to be able to factor beyond x squared. Up till now, you've only factored quadratics, and you've factored out common factors. But how do you factor something like 2x cubed minus x squared minus 2x plus 1? Because what we just wrote here, what we just figured out, when it has a remainder of 0, we can now say, let me write this out, we can now say that 2x cubed minus x squared minus 2x plus 1 is equal to x plus 1 multiplied by 2x squared minus 3x plus 1. And so we have started to factor 2x cubed minus x squared minus 2x plus 1. And because this is a quadratic, you already know how to factor that. You could factor this even further. How do we factor this? Well, it'd have to be 2x and x. To get 1 would have to be 1 and 1. Outside and inside need to make minus 3, so these will both be negative. And we just factored 2x cubed minus x squared minus 2x plus 1 completely. That's one of the things that we're going to be doing in this unit, learning how to factor. Well, if you get a remainder of 0, you know that it's factor. It is a factor. But the hard part is, how did we know to try x plus 1? If we're just guessing to start with, x plus 1, like in this case, x minus 2 didn't work. Gave us a remainder of 9. That's not going to help us for factoring. So we're going to learn skills that help us with those things. But this first process is learning how to do long division.